All right, welcome to class, everybody. I hope you guys are having a good day so far. So today we're going to cover section 5.5. Also, if you were not here last class to pick up your tests, I have them here, and I can hand them out during homework time. So our lesson for today is about factoring trinomials, which is kind of like an extension of what we did yesterday. So yesterday we talked about factoring by grouping, and we learned how if we have a polynomial like this, we can split it into two groups and factor the first group. So like in this group, we would have 3x in common. And so you could factor out the 3x. And when you divide this by 3x, you get 2x. When you divide this by 3x, you get 5. And then on this second group, you could factor out a -4. -8x divided by -4 gives you 2x. -20 divided by -4 gives you +5. And then because you have these two terms in common, or two factors, excuse me, in common, then you could factor out those common factors, which would leave you with a 3x minus 4. So essentially, factoring by grouping undoes the double distributing that we do when we multiply polynomials together. However, in most cases, especially with something like this, you don't actually end up with a polynomial that has 4 terms, because most of the time we'll take 15x and subtract 8x, and you end up with a polynomial that just has 3 terms. In which case, factoring by grouping doesn't really work because you don't have like 4 terms to split up into your two groups. And so what we're going to be doing today is we're going to learn how to split up 7x into 2 terms that will make it so that factoring by grouping will work. Because there's lots of different things that would add up to 7x. You know, like you could go 3x plus 4x, or you could do 100x minus 93x. Like there's lots of different combinations you could do. And so we're going to learn how to find the specific combination that will help you be able to do factoring by grouping when you're given a polynomial like this. So the strategy is you take your first and last terms. So like in this case, we have a trinomial, so 3 terms, and we take our first and last terms and multiply them together. So in this case, we would get -15x squared. And you want to find 2 numbers or 2 things that multiply to equal -15x squared and add to -2x. So in this case, I'd think about, okay, well, what are all the things that multiply to equal 15? You know, you could go 15 times 1, you could do 5 times 3, and it looks like 5 times 3 is going to be the right combination here, because if I want it to be -15, one of them has to be negative, and if I make the 5 negative, and I have -5x and +3x, those 2 numbers will multiply together to equal -15x squared, and they will add together to equal -2x. And so those are the 2 terms we're going to split -2x into. So we'll rewrite the polynomial as 3x squared minus 5x plus 3x minus 5. Once you have that done, then it's just like what we did yesterday. And you just do factoring by grouping from there. And so this step right here is really the only new stuff we're learning today. So to finish this out, we'd split this up into 2 groups. And what does the first group have in common? Yep, has an x in common. And when I divide out an x from the first term, I end up with 3x. With the second term, I get a -5. Then in the second group, what do those 2 terms have in common? Yeah, they don't really have anything bigger than 1 in common. And so we'll just write a plus 1. And when I factor out a 1 out of the 3x, you just get 3x, because 3x divided by 1 is 1. Same thing with -5. And from these 2 terms, we have a common factor of 3x minus 5. So I'll factor that common factor out, and I end up with x plus 1. And this will be the factored version of this polynomial. And if you wanted to test this out, you could FOIL this out or do whatever method you like using to multiply polynomials in order to get back to that polynomial. Because the whole goal of factoring is to take a bunch of things that are added together and convert it into a form where you have polynomials that are multiplied together. Any questions on this so far? And I'll go through some more examples of this, but do you guys have any questions so far? Okay, let's do another example then. So on this one, we're going to take the first and last terms and multiply them together, which gives us 10x squared. And I want to find two things that multiply to 10x squared and add to 11x. So what would those two things be? Say it again. Yep, 10 and 1 would be the numbers. And then I'd also want to include x's because 10x times 1x will equal 10x squared, and they will add up to 11x. So I'll split up my 11x into those two terms. So 11x becomes positive 10x plus x plus 5. Then I'll split those into two groups and do factoring by.
Why did you choose 10x squared? Is that the most common thing because of the 2 and the 5?
Yeah, so the trick, it's just kind of like a trick to make it so that you split up the 11x into two terms that will work. Because there's lots of things you could split 11x into, like you could go 5x plus 6x, right? Like that would equal 11x. But you need to find the specific ones that will work with factoring by grouping. So the 10x squared comes from multiplying the first and last terms together. And then you find two terms that multiply to that and add to your middle term. So it's just kind of like a trick to be able to do the factoring by grouping, because you can't do factoring by grouping with this since there's only like 3 terms, so you can't split them up into 2 groups. So the goal here is to split it up into 4 terms so that you can split it into 2 groups and do the factoring by grouping.
Thank you.
Yep, you're welcome. All right, so in the first group, we have a 2x in common. And when I factor out a 2x, I get x plus 5. In the second group, there's nothing in common there. So we'll say there's a positive 1 because anything can be divided by 1. And we get x plus 5 as well. Then these two terms have an x plus 5 in common. So I'll do x plus 5 times 2x plus 1. And again, if you want to check your answers, you can always distribute these polynomials out and you should get this same answer. All right. Okay. Do you guys feel like you'd be ready to do one on your own? Okay. Why don't you guys try this one and then we'll go through it together. And then I'll show you 2 other examples that are a little bit more advanced. All right, so on this one, I'll take my first and last terms, multiply them together, which gives me 15x squared. And what are 2 things that multiply to 15x squared and add to negative 8x? Perfect, nice job. So we have negative 3x and negative 5x because those 2 will multiply to a positive 15x because a negative times the negative is a positive. And if you add them together, it will equal negative 8x. So we'll write that out and we get x squared minus 3x minus 5x plus 15. So I split those into 2 groups. And you guys might have written it in a different order, but you should end up with the same answer as me. So like if you wrote it as negative 5x and then negative 3x, you'll still get the same answer. Your process might look a little bit different though. So when I factor out an x from the first term, I end up with x minus 3. And the second group has a 5 in common, but I'm gonna actually factor out a -5 because I want the stuff inside of my parentheses to match this set of parentheses. So since this has a positive x, I'm going to factor out a -5 so that the x is positive. So I'll factor a -5 out, and that gives me x minus 3 because -5x divided by -5 is just x. 15 divided by -5 is -3. Yes. And then I'll factor out x minus 3 out of both terms, and that leaves me with x minus 5. And so this is the factored form of that polynomial. Now you will also have a couple problems like this on your homework where you might have multiple variables. The process is still the same though. So you would take your first and last terms, multiply them together. You get 7x squared, y squared. And you're looking for two things that multiply to 7x squared, y squared, and add to 8xy. So let's look at the number first. What two numbers multiply to 7 and add to 8? 1 and 7, right? And then what would the variables be that multiply to x squared, y squared, and add to xy? Just xy, right? So those are going to be my two terms that I substitute in for the 8xy, and I get x squared plus 1xy plus 7xy plus 7y squared. Split those into two groups. The first group has an x in common, which leaves me with x plus y. The second group has a 7 in common, and a y actually, so a 7y in common. And that leaves me with x plus y. And it's good that my parentheses match because that means I can pull the common factor out, and that leaves me with x plus 7y. So even if you have multiple variables, the process still looks the same. You also might get some problems like this, where there's a greatest common factor that you can factor out before you do the trinomial factoring. Because remember, the easiest type of factoring is reverse distributing, where you just pull out a single term out of every term. And so in this case, since we have a 3 in common and an x in common and a y in common, we can simplify this problem by factoring out 3xy. And when I do that, 6 divided by 3 is 2. X cubed divided by x is x squared. And y divided by y is just y. Or I mean, it's just 1. And then for my second term, 15 divided by 3 is 5. X squared divided by x is x. Y squared divided by y is y. And then on the last term, 6 divided by 3 is 2. X divided by x is just 1. Y cubed divided by y is y squared. Is everybody good with how I got from there to there? And then at this point, we do have, like, this is technically factored because we have stuff that's multiplied together. We have a monomial times a trinomial, but this can be factored further. So it's kind of like, I think I gave you guys the analogy last class about like factoring numbers, where like if you have a number like 12, you can factor it into 3 times 4. But then you can also factor the 4 further into 2 times 2. So we need to do that, the polynomial version of that, because we've essentially factored it into 2 factors, but this can be factored further because it's a trinomial. So we're gonna go ahead and factor that part. And in order to do that, we're going to take our first and last term, multiply it together, which gives us 4x squared y squared. And I want two things that multiply to 4x squared y squared and add to 5xy. What would be the number part of those two things? Yep, I think I saw some people saying it. It's 1 and 4. And our variables would have to be xy, because if I add 1xy to 4xy, that would give me 5xy. So I'm going to rewrite this stuff inside parentheses as 2x squared plus 1xy plus 4xy plus 2y squared. And all of this stuff is still being multiplied by the 3xy. So keep that factor that we factored out earlier because that's still part of the expression. But we'll factor the stuff inside of the parentheses by splitting it into 2 groups. and it looks like I have an x in common from my first group, which gives 2x plus y. My second group has a 2y in common, and so that gives me 2x plus y inside parentheses again. And this whole thing is multiplied by 3xy. And I can pull out this common factor of 2xy from both terms there, which will give me 2x plus y. And then when I divide this term by 2x plus y, I'm left with an x. When I divide this term by 2x plus y, I'm left with 2y. And all of that stuff is still multiplied by 3xy. Now, this is fully factored because you can't factor any of this any further. And so this would be the final answer. And on this one, just like whenever you have a problem like this, make sure you remember to keep this common factor. You don't necessarily have to write it. Like if you want to on the side, figure out what this is and then like combine it all, that's fine. But don't forget and just write this part as your answer. You have to make sure you include that common factor as well. Did you have a question?
Yeah. How would you be able to recognize between maybe that process, but besides the other process for trinomials?
So this one is the trinomial process, but we do it at the second step. Like we first of all look through and see if there's anything they have in common, because that's the easiest type of factoring.
Yeah, I'm just talking about like the last problem we had trinomials, we didn't do the 3x on one side.
Yep. So on the last problem, the reason we didn't was because these three terms didn't have anything in common.
Okay, so if they do have something in common, then
Yeah, so if they all have the same thing in common, then you can factor that out first and then do the trinomial step. Yeah, good question. Any other questions? Okay. Can you guys show me on a scale of 1 to 5 how you're feeling about factoring? Okay, cool. All right, so the last, actually, this one is question 10. So if you guys want to open up your laptops, we'll start on question 10 if you want to work along with me. Okay, so your question 10 may look a little bit different than mine, but I think all of them have the same basic structure. So when we look at this, we basically have three terms that are being added or subtracted together. And they're rather complicated terms because they have parentheses and all this stuff in them. But when we look at those three terms, what do they have in common? Yep, we have an x minus 1 in common. And so I can factor that out and divide each of the terms by x minus 1, which will give me 3x squared for the first term, positive 8x for the second term, and negative 16 for the last term. And so that is in factored form, but it's not fully factored because the trinomial can be factored even more. So I'm going to see if I can factor this up into two more things that are multiplied together. And to do that, I'll use our trinomial trick that we learned today. I'll take my first and last term, multiply them together, and is it negative 48 x squared? I think that's what 16 times 3 is, but someone want to check that? Pretty sure that's right, because 3 times 15 is 45. And if you add 3, I think that should be right. So then at this step, I look at it and say, okay, well, if I have negative 48x squared, the two things that multiply to negative 48 and add to 8 are maybe 12 and 4, I think. Because if the 4 is negative, that would make them multiply to negative 48 and they would add to negative 8. So I'll split up my 8x into two terms and I'll get 3x squared plus 12x minus 4x minus 16. And all of this stuff is still multiplied by the x minus 1 that I factored out earlier. Then I'll split these into two groups. My first group has a 3x in common. I'm left with x plus 4. My second group, I'm going to factor out a negative 4 so that I'm left with x plus 4. And again, all of that stuff is multiplied by x minus 1. And then these two factors are the same factor, so you can factor that out. And you get x plus 4 times 3x minus 4. And that is multiplied by x minus 1. And then I look at all of my factors, and none of those can be factored any further. And so that means that I'm done. And this would be the fully factored version of the expression. So it's kind of like that last problem we did. The only difference is that the greatest common factor that we pulled out was an x minus 1 versus in the last one, it was like 3xy or whatever it was. So that's how you do question 10. I have a couple other questions that might be helpful to just go over quickly. On question 12, they're asking what polynomial when factored gives you this. So they're giving you the factored form and they're asking you what polynomial would be factored to be that, which basically means you just multiply those together to expand out the polynomial. Because remember, factoring undoes the multiplication, or like the foiling repeated distributing that we did a couple lessons ago. So on number 12, you would basically just FOIL this out, multiply these terms together. And in this case, you actually end up with a kind of interesting result, because when you do 5x times 5x, you get 25x squared. Then 5x times negative 2 is negative 10x. And then 2 times 5x is positive 10x. And positive 2 times negative 2 is negative 4. And what's interesting about this example is that your x terms happen to perfectly cancel each other out. And so that ends up giving you 25x squared minus 4 as your polynomial. And we're going to actually talk more about this pattern in class tomorrow, because this is what's called a special form. And whenever you have like two perfect squares subtracted to each other, you can kind of just factor it by taking the square root of each part. But we'll talk more about that later. But I think on all of the question 12s, this pattern will work out where the middle terms will end up canceling each other out, which will always happen whenever you have almost the same expression, but with a difference of a positive and a negative. So that's question 12. Okay, question 13. There's two different ways you can do this one. So the way that what the problem says is you have this trinomial, and one of the factors is 3x plus 5. So and then they ask you, like, what is the other factor? So one way that you can do this is you can factor the polynomial and look at which one is not the one that's 3x plus 5, because they've basically given you like half of the answer already. However, in this case, it's kind of challenging, because if you do 21x squared and you multiply that by 80, you're going to get, I think it's 1,680x squared or something like that. And if you go through and try to figure out what multiplies to equal 1,680 and adds to 83, like, it might take you a little while. You can figure it out, but it might take a bit. So if you want to figure that out, the way that I would recommend doing it is just to start guessing, so you might say like, oh, it's an even number. So I could have 2x maybe as one of my terms, and then the other one would be 840x. Well, obviously those don't add up to anything close to 83x. And so that means that I need to choose numbers that are closer together. So I might say, okay, well, I know that the square root of 1600 would be 40, because 40 times 40 equals 1600. And 40 plus 40 is relatively close to 83. So I'm going to guess kind of like in the 40 range and see if there's any numbers in the 40s that I could divide by. So I might start off by seeing, is it possible to divide by 40x? If I do 1680 divided by 40, I think, what is it? I think I remember from my last class, it was 42x. 42x. Okay, great. Yeah, so that one is really close because 40x plus 42x would be 40 or 82x, and I want 83x. So I know that I'm getting really close, but that's not quite the pair of numbers that I would need. So I might say, okay, well, let's make one of the numbers a little bit bigger. So if I did 42 and I did maybe like increased it to 43, does that number divide evenly by 43? It doesn't. I don't think it does from what I remember from my last class. But if 43 doesn't work, then try it out and say, does 44 work? Does 45 work? And just slowly increase the number to see what other numbers might work. 48. Okay, and 48x, what's the other 45? 48 times, 35. Okay, perfect. Okay, awesome. So 48x works, and it's factor pair, I guess you could say, is 35x, and those do add up to 83. And so those are the two that you would use. So you could write it out as 21x squared plus 35x plus 48x plus 80, and then split it into two groups. The first group has a 7 and an x in common. So you'd be left with 3x plus 5. The second group, what's 48 divided by 3? Because I want the stuff in the parentheses to be 3x plus 5. So whatever 48 divided by 3 is, that's probably going to be what they have in common. 16. So I'd have 16 times 3x, and does 80 divided by 16 equal 5? Perfect. So that would be my second group. Then I can factor out the 3x plus 5 and multiply this by 7x plus 16. And the question asked, they told me the polynomial and they said one of the factors is 3x plus 5. We verified that. That is one of our factors. And then they said, what is the other factor? So I'm only going to answer this term because they are asking for what the other factor besides 3x plus 5 is. So that would be 7x plus 16. So that would be the way you would solve this problem if you use factoring. However, there is another way that you could do it that I think is easier than trying to like figure out what two numbers multiply to 1680 and add to 83. And that method is the long division method we learned a little while ago. Because if you think about it, we're factoring this polynomial, which means we're going to end up with two things that are multiplied. Well, if they tell us one of the things that's multiplied and they say this times something else equals that, well, we could divide this by that to find the other thing. And you would get the same answer that we got solving it with this method, because if you do 21x squared plus 83x plus 80 divide by 3x plus 5, well, 21x squared divided by 3x is 7x, which gives you 21x squared plus 35x. Then you subtract those. And when you subtract 83x minus 35x, I think you get 48x plus 80. And then 48 divided by 3 is 16. And when I do 16 times 3x, I get 48x. 16 times 5 should give me 80. And when I subtract those, that ends up giving me a remainder of 0. And you can see I got that same factor that I got through the factoring method. So I personally think the long division method is easier. There's only one question like this on your homework where they tell you one of the factors. But if you have the polynomial and you know one of the factors, you can just divide that polynomial by the factor to find the other factor. So that's question 13. And then on question 14, it's not very hard. I just wanted to make sure you guys understand what they're asking. So on question 14, they want you to factor this polynomial and rewrite the equation. So in this case, we're not working with just a single polynomial. We're working with an entire equation where y equals a polynomial. And so you'll factor the polynomial and rewrite the equation in factored form. And then these 3 boxes are where you're going to plug in specific numbers and figure out what y needs to be. So like, and it's easier if you plug it into the factored form than plugging it in here. Because like, you'll see once you factor it, but like plugging in this fraction won't actually be too bad when you plug it into the factored form. Versus if you were to plug in 1/4 into this, you'd have to like find common denominators and it would get really nasty pretty quick. So on these ones, you're going to be typing in numbers of what y has to be if x equals these values. So those are all the questions I wanted to highlight. If you guys have any questions, let me know. Also, can you guys raise your hand if you didn't get your test back?